All right, hello everyone. My name is Jonathan Hill. I'm an engineer here in ATA's Northern Virginia office, and I'm really excited to welcome you all to today's webinar, which will be an introduction to the Femap API. Now, before I turn things over to Rachel in our Denver office, I have just a couple quick notes to share with everyone. So first off, we'll open things up for questions at the end of the demonstration, but until then, everyone is muted for now, just so we don't have any background noise or anything. When we get to the questions, you'll be able to unmute yourself. You can also ask questions at any time during the chat, either to everyone or just to me or Rachel, but we might wait and cover those at the end as well. And then finally, we are recording today's presentation. We should have it available on our website in the next couple of days, so keep an eye out for that if you want to rewatch part of it or share it with a friend or anyone. In addition, we're going to have a couple specific examples and demo APIs that you can try out yourself, and so we'll have those posted to the website when the recording gets uploaded as well. So I also want to give just a quick intro to ATA to start things off. So in addition to our role as a Siemens partner and reseller, we're also known for our robust engineering services, and really these two complement each other very well. When our software customers run into trouble, we're able to provide exemplary support by leveraging our experience overcoming similar problems across a wide range of industries in our services role. So on the services side of things, we offer complete integrated solutions with a focus on analysis and test-driven design. So whether we're analyzing next generation of planetary rovers or performing ground vibration tests on state-of-the-art aircraft, ATA is really proud to help our customers meet their toughest engineering challenges. And of course, being experts with the Siemens PLM software helps us do just that. So on the software side of things, ATA can assist you with a variety of product lines, including Femap, which we'll be focusing on today. But in addition to that, we can help with SimCenter Nastran, which was formerly NX Nastran, SimCenter 3D, NX, StarCC+, and even more. We have a technical support hotline that is staffed by experienced engineers who are using these tools every day. And so in addition to that, we can help with license sales. We offer a variety of classes covering everything from introductory to more advanced topics. And I'll also mention that Siemens has recently recognized us as a Smart Expert Partner based on our validated expertise with Femap and StarCC+. So after the webinar, I invite you to check out our software website. This has a schedule of upcoming classes and other webinars that we're hosting. It has a contact form for our hotline. In addition to that, it has the latest software product information and brochures, as well as links to free trials. I also have to mention that my favorite part of the website is going to be the free resources section. So if you come, it's going to be this yellow button here. And we have a ton of great stuff up there. So we have white papers, training videos, tutorials, APIs that you can download and use yourself. And then, like I mentioned, after today's presentation, we'll be uploading some specific examples that you can walk through just to kind of get started on APIs. So I would invite you to check out all of these resources after the presentation today. But with that, I think we're ready. So Rachel, it's all yours.
All right, thank you, Jonathan. So like Jonathan said, we will be talking about the Femap API and providing a basic introduction. So the idea here is if you haven't used the API before or haven't done very much with it, we'll hopefully answer a lot of your questions. So the things we'll be talking about are what is an API? Why is it useful? What are the types of objects used? Where do you go to write an API? And what do you do if you need help? And then we'll get into kind of some gritty nuts and bolts and some coding and show you how to edit nodes and elements using the API, get user-selected nodes and loop through them, write if statements, list data to the messages pane, use arrays and variants in your code, and use return codes. And then last of all, we'll cover things like what do you do if you get an error message, how to debug, that kind of thing. So a lot to cover today. We'll go pretty quickly, but like Jonathan said, the recording will be up if you need to go back and go over things, and all of these examples will be posted so you can go back and work through them on your own at your own pace. So first of all, what is an API? API stands for Application Program Interface, and technically that refers to the language and libraries that you can use to control Femap. But usually we just refer to the individual programs that people write as APIs. It's kind of a dual use acronym. So instead of opening Femap and going in with your mouse and clicking on tools and entering data, an API does those same operations either inside Femap or from another program like Excel. So you can kind of control it remotely, let it automate things. The API uses Microsoft's framework for communicating between applications, and the native language is Visual Basic, but really you can use a lot of other languages. Python, C# are pretty common, as is Visual Basic.NET and other varieties. And the API contains pretty much every command that's available in Femap. Every once in a while they'll put out a new tool in one edition and you'll have to wait for the API command in the next edition. But pretty much everything that you can do in Femap, there's an API command for. So the Femap API, it enables the user to automate repetitive or tedious tasks using computer code, and because it provides access to all the objects within the Femap model and the Femap functionalities. So one thing to note right up front is the button that you've seen that says Custom Tools. That gives you a list of other options that you can do within Femap. Well, all of those are APIs. So they were just APIs that the developers found handy. They knew a lot of people would want to use them, so they just included them with Femap. So you can actually go in and open these and edit them and read them and do whatever you want. If you just go to your Femap install folder /API. So you'll see the data structure in that custom tools window is exactly the same as what you see in that folder. And if you add things to this folder, they'll show up in the custom tools. So why use the API? Why bother learning it? Why take the time to write these codes? There's a bunch of reasons why you might want to do that. We're just going to step through a couple general examples to kind of help give people an idea, because it helps to put it in a real world context. So let's say we've got our analyst, Sarah, and Sarah just started analyzing a new design for electronics enclosure. And as with any brand new design, she knows that she's going to be working with the designer, going back and forth, changing thicknesses, moving gussets, going through all of that. And she's going to have to analyze this part a lot of times. And every time she needs to get that same results combination, which is an RSS of some gravity results, an X, Y, and Z, and with a factor of safety of 1.5, and a thermal result with a factor of safety of 1.2. So something that we see a lot as analysts. So let's look at this a little closer. She has to do something many times. My general rule of thumb is it under 10 or is it over 10, but it kind of depends what you're doing. Every time she has to do pretty much almost the same thing. I mean, her model will change, but she's going to have 4 output vector or output sets that she's going to have to combine. She's going to be using the same factors of safety. So she has to do that same combination every time. And she has some values that she would be entering by hand. So those 3 things that we identified, those are all reasons why she might want to write an API to do this. She'll probably save time in the long run. So it'll take her, a couple hours probably to write the API to do this. But if she has to do the results a whole bunch, that'll end up saving time. And by writing the API, she'll ensure that the combinations are performed exactly the same way every time. So you get that consistency, especially with those values she has to enter by hand. She could easily type a 1.4 instead of a 1.5 when she was entering the factor of safety, and that would make a big difference. So let's look at another example of why you might want to write an API. So Jim's lead analyst gave him this old model. It's an assembly. It's got, 100 BDF files that are attached. And so when he brings the stat file in, he gets all these groups. He can't find anything. That's a pretty common problem that we see a lot. And what happens here is you can, in Femap, it can tell you what elements are in a group, but not the reverse. It can't tell you what groups an element is in. So sometimes when you know the element you're looking for, but you don't know what groups it's in, that can be difficult. So this is something where he has to sort through a lot of things, which is something we all know computers do really quickly. but people do slowly. And he's trying to do something that there's not a ready-built Femap tool for. So that kind of indicates that he might want to write an API for this. So again, it's something he's going to save time. He won't have to go hunting through the model every time he wants to find what groups his element is in. And if he writes this well, he'll have a new tool that he can use in the future to do similar tasks, and he can share with his colleagues. So now he's spent, an hour writing an API, maybe a couple hours if he's pretty new to it. But now he's shared that with everyone in his company, and everyone's become more efficient. So well-written API, if it's made general and it has good error handling and that kind of thing, can be shared with others and help everyone out in the long run. So this one, the API that we're talking about with Jim, is called Find Element Groups. It's something we run into quite a bit at ATA and we find useful. So I figured I'd just demo it really quick. So we're in Femap, and we've got this helicopter model. So something common that we use, just pretty general. And kind of like Jim's example here, we have a whole bunch of groups. These are all different BDFs that were brought in. You can see some of them are nested. And we know we want to find element, let's see what I've got written down here, 12811, but we don't know what groups they're in. So we know we have Jim's API that he wrote. And so let's go ahead and run it. So if you want to open up and run an API that's not in your custom tools menu, you can go to Tools, Programming, API Programming. This will open up the API Programming pane. We'll be using this today to write and edit our APIs. There are other ways that you can write and edit them, but this is the easiest. It's built in with Femap, and we're going to focus on here because we have limited time. So let's use the Open button to open up the API. It's called Find Element Groups. And here's the code. So it's already written. We've been told that it runs good, so we're just going to go ahead and try to run it. There's a play button right up here. I'll work through what some of these other buttons do, at least the important ones later on. But for now, we just want to hit play. And APIs can talk to the user so they can ask for information. So it's saying, well, which element do you want to find? So we want 12811. Hit OK. And then the next thing it wants to know is, well, which groups do you want to search? So maybe at some point someone didn't want to search every group in the model, but that's what we want to do. So we're just going to hit Select All. And all this API does is it spits out this message to the messages window, which says, hey, we found this element in these groups. So now I know where to go looking for it. I know it's in 1 and 2, which are nested groups, and then down in 21. So now I know which BDF file I could open up to go find that element and make some adjustments. So a pretty useful tool. All right, so the API objects. APIs are written in Visual Basic, which is an object-oriented language. So you're using objects as kind of the base of the code. And these are things in your model entities, user face entities. So for elements, they have an object called femap.lm. For output vectors, femap.output, etc. They even have things that are not in your model, but in Femap, like the data table. So you can edit all of these things within the API. Objects have properties and methods associated with them. So properties describe information about the object. So for example, if you have an element, it has a topology, so it might be a C-quad or a C-hexa or something like that. So that would be the property. And then methods allow you to interact with the object. So you can change them, manipulate them, that sort of thing. So if you have a surface object, you might want to mesh it. So mesh would be a method. And then within the parentheses of a method, you might tell it specific things. So mesh is a pretty straightforward command, but some of the other methods need a little bit of input, or they might give you output as well. And we'll talk about how to do that later. A lot of times you want to create multiple instances of an object type. So you may want to have a search element and then a different element in the same code. And the way you kind of deal with that is you can give them names. By giving the object a unique name, now you have, each of them has its own set of properties. You can act on them independently using the methods. and that allows you to, and it just allows you to organize your code and know what you're talking about. So you would use a dim command that stands for dimension. So dim search elem as elem. So the search elem is the name that I'm giving it, and then the as elem just tells you what type of object it is. And then you can do in the same line, comma, and then give another one a new name, again, as elem. So this could be done like we're showing here in the same line or in different lines, different parts of the code. It just allows you to have multiple instances. There are 3 different classes of Femap objects. This is important to know when you get into the help file and start looking around. There's the application objects, which essentially provide your access to the GUI, the menu options, and things that happen just in general across the application. Some of those might be mesh curve, regenerate view, list to the messages window, that type of thing. And then second, you have your entity objects. So these are the things in your model itself. Everything you'd see in the model info tree. So your nodes, your elements, your analysis sets, your materials, those are all entity objects. And then the third class is kind of a special class, and they call it tool. And this gives you functionality that is its own thing, but it's not part of your model. So this might be the data table or the beam calculator. This is where you'll find copy and move tools. And it's also where sets are under. So we'll talk about sets more because they're unique to the API. You don't see those in other places in Femap, but they're very important and very useful. All right, so we just saw this briefly, but APIs can be written and edited within the built-in coding environment, Femap. It's probably the best place to start. So again, you go to Tools, Programming, and then API Programming to open up this pane. And when you're writing in here, what you're using is actually called the WinWrap Visual Basic. This is a kind of a subset of Visual Basic. It has most of the features, but not everything. It's a little bit different. But it allows you to do most of the things that you're going to need to do. You can write and run APIs directly from this pane. You can see what's going on. When you're typing, there'll be interactive pop-ups that help guide you and show you what's available. So, for example, as you're typing over here, it might list out properties and methods that are available to you. And then once you get into a method, it'll bring a pop-up saying, you know, what the different inputs and outputs are and the required data types. So this will help you out as you're typing and writing your APIs. And if you're using this pane, one thing that the program has to deal with is, well, if I push Control-Z, did I mean to undo the last thing I typed or the last thing I did in my mod fem? And so it has this, if you right-click in the programming pane, the first thing at the top is this toggle. It says Use API Shortcuts. And so that just essentially allows you to toggle between the two. So that's useful to know about. So while you're coding, you probably want that toggled on, and then when you go edit a model, you probably want to toggle that off again. All right, where to get help? This is important. This is where a lot of us will be going all of the time. I mean, I write APIs often, and I'm in here every day when I'm doing that. So there is a special help file for API. If you can access it through help programming in Femap, or you can go to your Femap install folder and open up the PDF. And the way this is organized is by those 3 object class types. So section 3 will have everything that falls under application, section 4 everything under tool, and section 5 everything under entity. And then below that, it'll be organized by properties and methods. So if you follow that, you should be able to kind of find what's available to you. And the reason I talk about that is because searching is really hard if you don't already know what you're looking for. So a lot of times you'll want to flip through the tree or maybe use context help to figure out the name of the method or the property that you want to use, and then go into the help file and figure out how to use it. So for where we're looking at here, you can see we're looking in set for a set, so it's under section 4, which is a tool. So 4, and then if we want to see what's available for the methods, we go under the second section of methods, and then it'll list all the methods available to use with that type of object. A lot of the application methods start with FE, so FE and then some sort of semi-descriptive name. So that's good to know about, especially if you're trying to search. And the other thing to watch out for, there are common properties and methods that are used for many objects, and so they might show up somewhere else in the help file. So things like ID, title, get, next, those are useful in many applications for different objects. And then the other thing that helps with searching is just to pay attention when you're generally using Femap for what Femap calls things. So it's not XY plotting, it's charting, and you would plot data series on the chart. And so when you're looking to try to program that, you would look for things that refer to charts and data series. The other place you would get help is on the WinWrap Visual Basic. So this is for things like your common variable types, which are integer, long, double, string, just general math functions. So you'll notice I have on here square root does not have a T, it's just SQR, so that's a little different. And then if you wanted to figure out how to write an if statement or for loop, you would want to look at the WinWrap Visual Basic help. And you'd open this up by going into your programming pane and just pushing F1. At that point, the context help will direct here instead of the normal Femap context help. So you can search for different commands. You can also just go online and Google WinWrap VB and then whatever you're looking for. And something will come up in Stack Exchange or something like that. Most general Visual Basic help will work with WinWrap, but not quite everything is supported. So just keep that in mind. I Google stuff all the time and I'll try it, and 90% of the time it works, and 10% of the time I'll have to go back and edit it a little bit, but at least we'll get you pretty close. All right, so we talked about how custom tools are APIs. So let's open one of those up and make a quick little edit just to kind of see how this would work. So the one I'm going to work with is called Convert Rigids to Active Beam. And the purpose, this API converts rigid elements to an activated beam property, usually to convert from a structural model to a thermal model or something like that. But in my opinion, it's hard to remember to go find and activate your beam property before you run the code. So for this demo, let's just open up that code, and instead of using the active property, edit it so that it asks the user to select the property. So we're going to go find the custom tool. So again, I'm going to open, and I'm going to go to where I have Femap installed. So just in my C drive, Siemens program files, which is probably something similar to what you have. The first folder in here is API, so I'll click on that. And recall, this is exactly what shows up in the custom tools window. So I'll just have to know where things are in there. I know this one is under element update, and then convert rigids to active beam. So this is exactly as it ships with Femap. I haven't edited this one before or touched it. It's exactly what you would see. And if I open it, you'll see it's not quite as nice as the other one I found. Oh, look, there's even a sub function. There's a lot going on here, and not a lot of comments. But to go in and do what I'm doing, you probably don't need to know a whole lot about what's going on. You just kind of have to know what you're looking for. So what we want to do, remember, is instead of using the active property, we want to ask the user for a property. And that happens right at the top here. So you'll see we're defining properties. This is some line that's looking for an active property, so that's probably what's finding the active property, setting it to that ID variable, and then going and getting that ID. So these are the lines that we're going to be looking at fixing. So I'm going to go ahead and just comment them out by putting an apostrophe at the beginning of the line. So that means the code is still there. If I screw it up or want to go back, I can just uncomment it and delete what I added. And then I'm going to add my own lines. So instead of the get and the active, I'm going to use, so you see as I type, as soon as I push that period, it brings up some of my options here. And I know that I want to use select ID as my method. And what this will do is bring up the normal user selection window for properties and let the user select as they normally would in Femap. And if as soon as I put my parenthesis on, it says, okay, I know you're using this method. This is what it takes, and it's just giving me a shorthand. So I could go into the help and actually see what's going on with this. But really, you can read here, all it wants is a title, and it's just a title for that selection box. So we're going to say select rigid beam property. Space. So close that out, and when I push enter, you can see it colored it. I can tell that this gold color, that's my text that's going to show up. So everything is looking good. And then the other thing that these two did is it set up in the first line, it assigned this BPID variable. So I want to maintain that so that it can use it later in the code. So I'm going to say BPID, and that what it's asking for is just the ID number of the property, which I can get from my user selection object, so bprop, that's what we just set, and then dot, and we're going to use the ID property. So all that's going to do is pull the ID number from the one that the user just selected and store it in this variable so that it can be used in the rest of the code. And that's it. So I just had to change a couple lines, and now it changes how the code runs. So instead of having to remember to go find my property first, I can hit run first and then go find it. So I've got a good example model for this over here. I've got some rigids clamped in a couple of brackets. So you can see my tree. We've got 9 rigids in here. I've already created this rigid beam property that I'm going to use, but it's not activated. So let's test our code. So we'll hit play. And what does it say? Select rigid beam property. That's exactly what we're looking for. So we can say I want to use the rigid beam, hit OK. And then this is going back into the rest of the code that we haven't even touched. So it's saying which elements do you want to convert. Let's convert all the rigids you find in the model. You can see it's running, creating some beam elements, and we can see the update here. So that rigid beam property created the rigidness by having a very large diameter, which you can see with the cross sections turned on. So we have our update. That was it. Pretty straightforward. So even though there was all this code down here, we didn't even need to worry about it. Just focus on the one little area we were working on. All right, so now we're going to jump into some more examples and show you how to do some pretty basic tasks. The idea is we don't have a lot of time here, but you can take these tools, put them in your toolbox, learn how to use them, and then work them into bigger and bigger codes. So the first one we're going to do is just edit an entity. So we're going to change the color of node 12 in our model to red. So pretty straightforward. Everything's hard-coded in. One note before we start is that every color in Femap is defined by an integer value. You'll probably have seen this in the color palette, or when you click OK in a color palette and it puts that number into whatever box you were selecting. You can also go into section 3.3.7 of the API help guide, and that lists all the Femap constants. And one of those tables is for colors, so it'll have a whole list of color names and the color ID numbers for them. So you can see how that goes if you're ever using colors. So let's go back into Femap. Then all right, so you'll see I already kind of set this example up with some comments. This is something I highly recommend you doing, especially when you're learning, but even as you become a better and better coder, is first kind of outline what you're trying to do with comments, and then you can kind of focus on each step and get each step working on its own. And that allows you to just not get overwhelmed and just work on one little thing at a time and get that working. So we're going to first look at step 1, which would be to dimension our node object. So we want to create a node object. That was that dim command that we looked at. So dimension, I'm just going to call it my node. And then we need a second line, and the second line is going to connect this MyNode object that we just created to our model. So when you open up any new program in this programming pane, it's going to automatically put in some stuff for you. And one of those are these first 2 lines. And all that's doing is saying that I'm going to go find the current Femap model, and I'm going to call it APP. And that just activates the model, sets it to an easy name that you can find again, essentially creates this Femap application object that everything else is going to go back to. So we need to associate our new MyNode with that application. And the way you do that is with a set command. So set MyNode and an equals sign. And then we're going to associate with that APP, so application. And what type of object is that in the application? So it's an FE node. So a lot of these will be FE and then whatever type of object it is. So FE node, FE elem, FE output, that kind of thing. And again, as you type, it's going to kind of suggest where you're going. So you don't have to memorize all these. You'll see it as you go. So now we have our node object. Step 2 means we need to go set that node object to node 12. So go get node 12. So we're going to start with our object, my node, dot, and then get. So we're going to go get, parentheses, and then it wants the node ID, so that's 12, close parentheses. So that's it. So now my node is associated with node 12. And now we want to edit the color. So my node dot color equals, and then this is where those color names come in. So I could just type 4, that's the just basic red in Femap, or I could say FCL underscore red. And that's equivalent. FCL red is a Femap constant that equals the number 4. So now we've set the color, but we haven't saved the change. So it's very important to save after you make a change. Otherwise it won't hold. And you do that using the put command. And again, we're still working with node number 12, so put 12. So we've dimensioned our node object. We went and associated with node 12, changed the color, and then saved that change using put. So get, change, and put. You'll see those get and put commands. That's very common. All right, so let's test this. We can see on our model here, node 12 is just that center node. So I click run, and it played. Doesn't look like it did anything. The reason for that is we didn't do any sort of view regenerate in here. So it probably changed it, but it hasn't regenerated the view. So I'll just double click in the window to do that. And you can see now that node color is updated to red, just like we were trying to do. So again, pretty simple, but it gives you some tools to work with, and then you can start building up to more and more complicated things. All right, so the next thing to talk about are sets. So Femap API uses the set object to hold lists of ID numbers. So the set holds, all it holds are ID numbers. It's not associated with a specific entity type or anything like that. And they're just a special tool that are used to hold a bunch of user-selected IDs, to define multiple entities when you're using the methods, to loop through entities. And they're just a great alternative to trying to use groups or array variables and other things like that to try to hold IDs. They're special built for this task. They're very efficient. They work very well. And you almost have to use them, especially with the methods. They're set up to work that way. So we're going to do an example using sets. We'll also introduce you to user selection and while loops. So we did a little user selection before, but this is just showing it to you again because it's a very common task. So in this example, we will have a user select several nodes and then write a while loop to perform the same task for each node. So again, step 1 is going to be dimensioning. You're going to be dimensioning a lot. It usually just gets done at the top of your code. So we're going to dimension our set. So again, I'm just going to call it my set. And remember, we need that second line to attach it to the application. Now this is where it gets confusing because we're using a set object and a set command, but that is just how it's done. So we've now dimensioned it, we've connected it to our application, so we're good to go. Step 2 is to have the user select nodes for the set. So that's going to but I know it's probably going to be something like select. And sure enough, there's a select and a select ID and then a whole bunch of other things. If we want them to select multiples, it's just going to be the regular select command. So select, open parentheses, and now we can see some hints of what we want to do. You could at this point go look in the help file if you needed more information, but I'm just going to walk through this to save us some time. So the first thing it wants is what type of values are you selecting? And we're doing nodes, so you can see all these start with FT, so I'll type FT underscore, and then start typing node. You see that pops up right away. So node is an option, so we'll use that. The second thing it wants to know is, do you want us to go ahead and clear out that set before the user selects new ones? Just in case there's something already there. We just dimensioned it, so there probably isn't anything, but might as well set this to true just in case. And again, it wants a title for that selection box. So I'm going to say select nodes. Since this is title, it's in quotation marks because that'll make it a string. And that's it. So that'll bring up the selection box for us. And then step 3 is the new part. So we're going to use a loop to go through all the selected nodes. And this is why we went with the set, because it makes loops really, really easy. So we have one command called reset, and all this does, it doesn't even take any data, you can see, but it just resets the pointer of that set to the first entry. All right, we're going to start at the beginning of the list, and while, so we're going to use a while loop, so while my set has another entry, so next, and this next command we'll just go to the move the pointer to the next object and essentially activate it so you can work with it. So myset.next. And then when I hit enter, it auto-populates the closing statement for a while loop, which is WEnd. So you want to leave that in there. And now everything that I put in the middle between while and WEnd, that's what's going to get executed every time I go through my loop. So I'm going to do some stuff in here, maybe change some more colors, maybe move the nodes around, maybe list them to the window, whatever I want to do. It's going to go to WEnd, and then it's going to jump back up to the top and go to the next thing in my set, and then do that code again. And it's going to do that until there's nothing left in the set. So it's been through the entire set. And that's where we're going to stop on this example. We're not going to actually make it execute anything, but you could really write in whatever you wanted to here. All right, so the next example, we'll talk a little bit about if statements. So that's another thing you will commonly want to use, and writing stuff to the messages window. Let's see. So what we're going to do is have the user select a material, and we're going to look at that material, and if it's isotropic, we're going to write out its material ID and title, and if it's not isotropic, we'll have it just write out a message saying non-isotropic material selected. So that's pretty simple, but you could see expanding this to, instead of just writing that out, maybe figuring out if material is isotropic, and if it is, editing the values in a certain way, and if it's non-isotropic, doing something else. So just to save some time, steps 1 and 2 are already started for us. We've been through that before. So we dimension a material that we're going to use, and we ask the user to select it. We use select ID here because that forces the user to just select one thing. So we just have one material. It's selected. The select ID also activates it, so we don't need to use a get command after that. It's already there. So we're going to jump to step 3 to check if the material is isotropic. So this is the if statement. So if my mat, and the property we're looking for is type. So if the type, and when I hit it equals again, it's helping me. So it's saying, okay, I know you're looking at type. Here are all the types that you can select from. So FMT isotropic. Just hit enter, it'll fill that in to me. So now it says if we're using isotropic, and it put this closing end if statement on there, but it did miss something. So up here I have to write then, because you'll see these as if, then, else statement. The else is optional, but the then is required. So we have if, then, and what comes next is everything that happens if the statement is true. So I'm just going to write a little note to me reminding myself. So if we are isotropic, we wanted to print out the material ID and the title. It's easiest when you're printing these long messages to have some sort of string object to store them in. So I'm going to hop up to where I dimension the material and get myself a text object. So dim, I'm going to call it txt, so that's whatever name I want, as, and then a text string, or it's called string. So this would be characters. And since this is just a general variable, I don't need to associate it with my Femap model, so all I need is that dimension line. So if it's true, I want to make this text object equal to the material ID, so my mat.id. And one thing to watch, my mat.id is going to spit out an ID number, which isn't going to be a string. But since text is a string, we have to make those variable types match. There's a command you can do called cstr, or convert string, and I can put parentheses around that, and all it does is it takes whatever's in here and converts it to a string for me. So now it'll match type. Now if I want to add some strings together, I just use a plus sign. Let's add a couple dots just so we can see the ID separate from the title, and then we want the title. So my mat.title. And title will already come in as a string, so it's good to go as is. And now we are to the else statement. So if we're not true, so else, then we wanted to have it spit out just that we grabbed a non-isotropic material. So non-isotropic material selected. So just a quick message to the user. All right, so now we've done the if statement. If it was true, our text equaled one thing. If it was false, our text equaled another thing. And now in step 4, we're going to write that message text to the messages window. So that's in application method. So APP is our application. And the method to write out to the messages window is FEAP message. And the first thing it wants to know is which color, because you'll notice when things go to the message window, they might be bold, they might be red, and that indicates whether they're highlighted or an error or something else. I'm just going to say 0, which is equivalent to normal, so just regular text, and then it wants the message text. This was our txt object that we had defined, so that's all it needs there. All right, so if we click play, let's look at this model first to see what we have. So we do have a couple materials here that we could select, so we'll try both of them and see what happens. So play. So this is our select ID window that came up. Let's try steel first, hit OK, and we get the ID and the title. So that must have been an isotropic material. And we'll play and select the glass. And that one's a non-isotropic material. So just what we typed in here, it even caught my, lowercase m that was accidentally put in. So that's all there is to that one. So now you've seen an if statement. We've written out something to the messages window. So things are getting a little more complicated. And to even go further with that, we're going to start talking about arrays and variants. So arrays are a set of values of a single data type. So as opposed to the sets, which are just IDs, arrays are more general. These are just general to Visual Basic, so they're not a Femap object. So they could be anything. They could be integers, they could be doubles, which would be like real numbers with a decimal place, that sort of thing. You define arrays by dimensioning and then adding, oops, sorry about that, adding in the array size in parentheses after the name. Arrays are indexed at 0, so if you want 3 elements in your array, it would have a size of 2. 0, 1, and 2 would give you 3 elements. So in this example, I'm using long. Longs are a type of integer. That's what you'll probably almost want to use if you're going to be putting in integers, IDs, that type of thing. You'll just use a long. There are a couple other integer data types for specific situations, but this is probably the most general one. And then one thing to note, if you don't already know what size you want your array to be, you're going to have to dynamically set it. So let's, for example, say we want our array to be as long as n vals. Whatever n vals is, however that's set, that's how big we want our array to be. So we've dimensioned this n vals. Somewhere in the code we set it to 3, and then we want to use it. So the first thing we want to do is dimension the array as dynamic, and the way you do that is with empty parentheses. So my array, empty parentheses as double. So now it'll take real numbers, but it doesn't know how big it's going to be. And then somewhere in the code along the way, we're going to redimension, so redim, my array, and now we can use that variable name. So if you just try to put the variable name in a straight dimension command, you'll get an error message, it won't work. But if you use these two together and put it in as the redimension, you're good to go. So the key to arrays will make your code more efficient. They're faster and they're easier to write and edit, especially when you're doing the same thing to a lot of stuff. Basically, any other time you think of using arrays, that's what they're for. And then the last thing that's kind of associated are variants. So variants are a special data type that can hold anything. They can hold any kind of data. And so the way Femap API uses this is to output arrays, used in a lot of different ways, but this is the most common. So whenever you're getting output from a method and it's an array, it doesn't matter if it's an integer or double or titles, in strings, it's always going to be put out as a variant. So if you see an array of anything, any data type as an output from a method, you'll want to have a variant defined to accept that. So what does that mean for the code? Well, let's walk through an example and kind of see how the arrays and variants work. So in this example, we're going to just write out the x, y, and z coordinates for nodes 1, 2, and 3. And we'll use arrays and variants to do that operation. There's a few different ways to do it, but we'll use arrays and variants today. All right, so again, I have part of this already coded just to save us some time. So we're going to dimension a set just like we've done before. And then in step 2, we want to dimension and fill an array with the node IDs. So we're going to call it node IDs. Pretty simple. Oh, I forgot the dim, right? Dim, node IDs. And nodes 1, 2, and 3. So there's 3 of them. So our size is 2. Remember, we're indexed at 0. As long, because we're doing IDs, they're integer values. And then we have to set them. So node IDs in position 0, or index 0, is going to be equal to node 1. Oh. You can see it's trying to update my capitalization. So capitalization needs to be consistent throughout your program. And it'll try to help you with that if you mess it up. And so I'm just setting by hand each of each position, 1, 2, 3. If you had a whole bunch of these, maybe you'd create a loop or something to define them. But I'm just typing them in this case. And then step 3, so this is written out for us. All this does is it takes our node IDs array that we just defined, that's 3 elements long, and it adds the array to this set that was created. So now those node IDs are stored in a set so that we can use them in the method. Step 4 goes with step 5, which we'll write. So we're going to use a method called getCoordArray, which is a method that operates on nodes, and it's essentially it spits out the coordinates for a list of nodes. And we could verify that by going into help. So let's go ahead and do that. So I'm just going to copy the name because I already know the name. And remember, help programming, that's how we find the help guide. Just going to paste my name, list the topics, double click it to find it. So this is what you see in the help guide. So it has the method name. You'll notice if I look up here, we're under node objects and node object methods. So these are methods that go on nodes. It gives me a description, so retrieves arrays of coordinates for a set of nodes. That's exactly what we want to do. It has some input and output. So it'll always take input first, and you can see set ID comes first up here. So if you need to check the order, you can see the inputs up here as well. So set ID is going to be an integer value, and it's the ID of the set that contains the node IDs. So it'll be the ID of our node set, back up here. And then it's going to spit out some output. So these are things that we don't have values for yet. That's what's going to come from the method. But what we do need to do first is dimension variables to accept the output. And it's important to look in the help guide or use the context help to figure out what kind of variables we need for that. So the first one is an integer, and it's just the number. And it's the number of nodes for which data is being returned. So that one is just a simple integer, so we're going to use a long. You can see up here in step 4, I've dimensioned num node, and I just use the same names as they use, because why not? Keep it simple. As long. The second thing it's going to give us is each entry, so a list of the IDs of the nodes that's listing. This is going to be an array, and I can see this here by the square brackets and the length of the array that they're specifying. So they call it entID, and it's going to be an array, and since it's an array, they need a variant data type. So we have entID as variant, so we created that one, and then the last one is going to be the list of coordinates. So they're going to spit out, if you kind of read between the lines here, what they're going to spit out is X for node 1, Y for node 1, Z for node 1, and then X for node 2, Y for node 2, Z for node 2. So just a one-dimensional list. It's not a matrix, but that's how it's going to be spit out. Again, this is an array, so it's going to be a variant data type. So notice this one was an integer, this one was a double, but both of them are going to be variants in our code. So step 5, now we've got our variables for the output. We have our input set, so we're ready to execute the method. So we're going to say, now you'll notice we dimensioned a set, we haven't dimensioned a node, and our getCoordArray acts on a node. So we are just going to use the general FE node that goes with our application, so that we can access that by saying application.fe node. I kind of change that application object and just a general node object. And now we can use our getCoordArray method. You can see there's another getCoordArray too that probably has some other options if we want to look it up. But we're just going to use the regular one. And this should match just what we were looking at in the help file. So we have a 1 input and 3 outputs, and they're reminding us what they need to be. So our input needs to be a set ID as a long, and we should have long, variant, variant as our outputs, which exactly matches what we put up here. So to get our set ID, we want our node set dot ID, gets that ID property for us, and then our 3 outputs, so num node. I call them just the exact same as they wanted to, so everything matches, and that's it. So 6 is already written out for us, but what this is going to do, let's walk through it. Again, we're going to write to the messages window, so we might as well have a text object ready to put some information into. And then X, Y, and Z doubles to contain those coordinate information. And then we have a for loop. So what will have spit out of the get coord array are this list of entity IDs and the list of those coordinates. So we're going to walk through that array of coordinates. So step through 4. We need a counter variable. Let's call it I. That's pretty typical to use I, then J, then K as your counters, but whatever you wanted to use. And then we're going to step through from 0, because we're indexed at 0, to the number of nodes -1. Again, we're indexed at 0, so we subtract that -1. And then I do some kind of fancy math here to get out the X, Y, and Z, because they're all in that same table, all squished together. But if you wrote it out, you would see that if you get, 3 times our number of nodes, you would get the X position. Add 1 to that, you'll get the Y position. Add 2, you'll get the Z position, and then reset, and you'll get the next node. So that's how that works. So X, Y, and Z will be the coordinates. Put it into a text string. Remember to use those converts on numbers, and then we'll spit it out to the window. So let's see how this works. So I hit play. Remember, we didn't ask any data for the user. We just hard-coded in nodes 1, 2, and 3. And what we got down here was node 1 is at the origin, 2 is along the x-axis, and 3 is our diagonal. If we look up at our model up here, that's where they are. So 1's at the origin, 2's along the x-axis, and 3 is the diagonal corner. So it looks like it worked. All right, so I'm going to get into some debugging stuff. It looks like we're going to go just a little bit long, so I apologize for that. But that's all of our examples, and that's a lot of the big information. So we'll just jump through this last bit pretty quickly, and then we'll get to some questions. So return codes are used to handle errors and other kind of events in the code. It could be an error. It could be as simple as the user selecting cancel in a dialog box. But basically what a return code will do is before you do, say, a select ID or really any method, you can type an RC equals, and then when it executes this method, it's going to spit out a return code. And depending on what your method is, it could give you different options. A list of all the return codes are in this table on the left. You can get that from the Femap constants page, again, in the help guide. And for select ID, there's 3 options. If it spits out -1, like anything else, it's okay. Everything worked, we're good to go. So keep going through the code. If it gets a 2, that means the user pressed cancel. So usually you'd want to exit the API immediately. So down here in our example, if RC equals 2, so our if statement, just like we did before, then and there's a special statement called exit sub, which will just exit the subroutine. Won't spit out an error message, it'll just end right there. If our return code equals 4, that means that nothing exists. So in this case, we're trying to select a material. If there are no materials in the model, it will give us a return code of 4. So in this case, you might want to pop up a message to the user saying, hey, you tried to run this, but there weren't any materials. So if RC equals 4, then we pop up message box, no materials found in the model, and then again, immediately exit. You don't want to try to keep running the code without any materials selected because it probably won't work. So that's one way you can kind of handle what happens within codes using the return code feature. And again, it can be used with any method. Just put RC equals in front. The RC really can be whatever you want to use. It's just that's what's typical and standard. So if someone else opened up your code and saw RC equals, they would immediately know this was a return code. Now the other type of error that you'll run into is when you actually have an API error. So you'll get a message to the message window in red. It'll look something like this at the top. First, it'll say API error, which tells you that it was an error with the API and not with the model itself. It'll tell you which line the error occurred on. This may be the line with the error. In some cases, it's later. So if you, say, forgot to put your closed quotations around something, it might think you have a really, really long string and then close it eventually, and that's where the error will occur. So could be a little bit off, but usually it's the right line. And then they'll give you a summary. So there's a few different common summaries that you'll get. If you see type mismatch, this means that either a variable was not dimensioned or you dimensioned it to the wrong type. So remember, we were very careful, especially with those outputs, of setting the type to match what it was expecting. If you get that mixed up, then you'll get a type mismatch error. So the way you fix this is to check your help resource to determine which type should be used and make sure to change it. And always remember, if it's an array, use variant. Another thing you can see is either not an object reference or object vars nothing. And that means you're trying to reference an object that you haven't defined, that you haven't dimensioned, it doesn't know what it is. So that means either you need to go back and dimension your object, and remember that set line as well, or just double check your spelling. A lot of times you'll see this if you just misspell the object name. Parameter requires an expression. That means that you are missing an input or output in your method definition. So that whole list of things that go in the parentheses, instead of having 4, you only have 3. So again, go check your help resource to figure out what needs to be there and then add it. You might see an expecting and then some sort of character, and that just means you're missing a required character. So you didn't close parentheses or quotations, you forgot your then in an if statement, something like that. If you see an unterminated block statement, what that means is you have what's called a block statement, so one of those multi-line ones like an if or a while or a for, but you're missing that end part. So for an end, it's the end if. For a while, it's the w end. For the for, it's the next. So remember, you have to match those up. And then make sure it matches. If you think you have the right statement, again, double check for unclosed quotations because that can mess things up. But those are probably the most common ones you'll see. I'm sure there's many others, but that should at least get you started. Now, when you run across these errors, you're going to want to do some debugging. So this is what you call when you go back into your code and try to fix it. A couple of tools you'll probably use are breakpoints and step into. So breakpoints mark certain lines, and it'll pause before it executes that line, so that you can kind of check what's going on, see what different values are, make sure your code's working. So to create a breakpoint, you just put your cursor in the line you want to stop at, and either click that hand stop sign or press F9, and that'll toggle the breakpoint on and off. You'll see a red circle, and it'll highlight the line in red. The yellow here indicates that I'm paused at that line, so I've been running. The other thing you might use is step into. So instead of playing the entire API like we've been doing, this would play it line by line. So it would run a line, pause, and then you push the icon or F11 again, and it runs the next line and pauses. So you can kind of just step through your code and see what's happening. And while you're doing this, you'll want to kind of on the fly check what variables are and things like that. You can use this with those application messages, or if you just want to check stuff on the fly, you can click watch. This window will pop up when you're paused, and you can just type in a variable name in here. If it's part of an array, you include which entry in the array it is and push enter, and it'll give you the current value. So it just allows you to check things as you're going. All right, and so last of all, just some recommendations. We've kind of gone through these before, but just to emphasize, I know it's new. I know codes can seem really intense when you first open them, and they're long and you don't know what you're looking for. But the biggest thing to do is just break it up and look piece by piece. So first of all, if there's something you want to do and there's a similar custom tool, go and edit it. Use what's already been done. That's the best thing to do. But regardless of whether you're starting new or adding in, start by just writing comments. Again, use that apostrophe to write a comment line that outlines what you want your code to do. So just comments of, hey, do this step, then do that step, just like our examples had. And then you can focus on one step at a time, figure out how to get that to work, write a test code if you need to, and just get that to work, comment it, debug it, get it just the way you want it, and then move on to the next task. And if you break it up like this, then even beginners can write some really cool, complex APIs, because you're just looking at one little thing at a time, and you get that working, and then pretty soon, you go back an hour later, and wow, you've written a lot. And it does some really cool stuff. So just try to keep it simple. If you're trying to figure out an already written API, like one of the custom tools, do the same thing. Just break it up. Look at each line, look at each block, write a comment saying what that line's doing, and move on. And then once you have written out your comments, you'll be able to see the whole picture of what the code's doing. And then you might as well leave those comments in. They'll help you remember what you did. They'll help the next guy. So best advice I have for everyone starting out is comment everything and keep test running. So debug, do one little line, test it, make sure it works, move on to the next line. So just keep debugging. Don't wait till you've written code for an hour and then go back, because you'll forget what you were doing. That's all I have for you today. So Jonathan will let you guys talk now.
Great. Yeah. So thank you, Rachel. Like Rachel mentioned, you can now unmute yourself if you want to ask any questions. I have pictures up on the screen right now of both the Zoom application and the web interface. Basically, in the bottom left-hand corner, there should be an unmute button. You can also ask in the chat if you're interested in submitting questions that way. While you guys are doing that, Rachel, if you write an API in the programming pane, does that automatically get saved anywhere? And then how would you add that to custom tools, or what's the difference between that and user tools?
Okay, yeah, that's a good question to get started. So when I'm working in the programming pane, I have a couple of buttons up here. So save and save as. So after I have written my API and I want to save it, I can do a save as and a save and keep that recorded. That'll just put it in a file somewhere. So when we're talking about the custom tools, like I said, that's just pointing to a directory. If you want to have it show up in custom tools, you just save it to that directory. But Femap also gives you this second directory called user tools. And I have mine set so it goes to a different folder on my computer, and that's essentially all it is. So you'll see nothing up here initially, and you can just go down here and say tools directory, and then specify which folder you want it to use. And if you save your APIs to that folder, they'll just show up right in this list for you. That's what user tools does. Are there any other questions?
Bryce asked if we will be making the recording available, and we will be. It'll either happen tomorrow or Monday would be my guess. We'll have that posted to our website soon. In addition, the different examples that Rachel went through today will be posted too. So we'll have both the before and after codes written so that you can kind of practice going through and building those up. Well, thank you all for attending. If you come up with questions later on or anything like that, definitely reach out and let us know. We're here to help you guys. And otherwise, have a great afternoon. Thanks, everyone.